Welcome back, students. We'll be looking at section 5.1, practice problems for the product rule and power rules for exponents. So remember, our product rule is this rule right here. We add our exponents when our bases are being multiplied. The power rule is when we have an exponent raised to an exponent and we multiply those exponents. So these are just a quick review of the new rules that we learned, and we're going to be using those in these practice problems. All right, so in our first one, I noticed that my base number is a -9, and they're the same base number, so that's good. So now I can actually use the product rule to combine my powers that it's raised to. So I'm going to write -9 to the power of 8 plus 5. So that becomes -9 to the power of 13. All right, number 2. I have these x's being multiplied against each other, so I'm going to use the product rule. So I have x to the power of 3 plus 8 plus 13. So I end up with x to the power of, well, 3 plus 8 is 11, plus 13 is 24. And that's our answer. Number 3, 10a to the power of 7 times -a to the power of 3. These are different bases. The a's do not match, so we cannot actually combine these. Even though they're the same letter, one of them is a positive, one of them is a negative. So at this point, we can't combine them. Now, later on, we'll learn a new rule that will help us combine these. But for now, we can't do that. So we're going to put different bases. So can't combine. It will stay like it is. Number 4, we have -5w to the 8th times -9w to the 6th. Our -5 and our -9 are different, but that's not what matters in this one. What matters is the w's. We have matching w's as far as they're both the same power. That's different than the previous problem where one was positive and one was negative. So we can actually combine these. But we need to remember when we combine, our -5 and our -9 actually multiply against each other like usual. So I'm going to get a positive 45. My w is going to follow the product rule. So I'm going to have 8 plus 6 here. And I end up with 45w to the power of 14. Scroll up here a little bit. Number 5. I have 5 to the power of 4 times 3 to the power of 4. I can't use the product rule here. Doesn't mean we can't solve it. I just can't use the product rule. So I'm going to write that here. Can't use product rule. So the way I would have to solve this one is I would actually have to do 5 to the power of 4, which is 625. 3 to the power of 4 is 81. And then when I multiply those together, I get 50,625. So again, the important part about this particular problem is I wanted to point out we can't use the product rule. We have to actually work with the exponent to get a number, then multiply our numbers. Number 6, 2 to the power of 3 plus 7 to the power of 2. Here again, we can't use the product rule because this is an addition problem, not a multiplication problem. So I'm going to put can't use product rule. Now, that doesn't mean we can't solve it. It just means we can't use the product rule to solve it. So 2 to the power of 3 is 8. 7 squared is 49. And we get 57. So again, we can solve it, we just can't use the power rule to solve it. Number 7, we have 7r in the parentheses to the power of 3. So remember, with this kind of problem, we have to distribute that 3 to everything in that parentheses. So I have a 7 to the power of 3, and I have an r to the power of 3. Well, 7 to the power of 3 is 343, and then the r to the power of 3 stays the same. Number 8, I have a -4 to the power of 2 in the parentheses with a 3 outside the parentheses. So remember, we have to pay attention to what's out here because that's what's going to determine whether this stays negative or positive when we bring this number out of the parentheses. That's an odd number, not an even number. So when I bring this out, it's going to be a -4 and then 2 times 3 up here to figure out what our exponent is. That becomes -4 to the power of 6. We don't have the parentheses, so our number is going to stay negative. And when we do that 4 to the power of 6, we get 4,096. But it's going to be a -4,096 because that's not in parentheses. Number 9. We have a similar situation here with a negative number in the parentheses. But where the last one had an odd exponent on the outside, this one has an even exponent on the outside. So when we pull that number out, it's going to be a +4 this time, and then 2 times 4. That becomes 4 to the power of 8. And that gives us a positive number, 65,536. So that just shows you how quickly these numbers can become super large based on how many it's multiplied times itself. Number 10, 5xy to the 8th. All of that's in that parentheses to the power of 3. So that's everything in there is considered the base of that to the power of 3. So I have to distribute it to everything in here. So I get 5 to the power of 3, x to the power of 3. Because remember, they have an invisible 1 with them, and that 1 times that 3 gives us the 3. Y to the power of 8 times 3. Simplify that out. 5 to the power of 3 is 125. We keep that x to the power of 3, and y becomes to the power of 24. Number 11, we have a 2 outside the parentheses, and then we have 4x squared y to the 6th power inside the parentheses, and all of that is raised to the power of 3. Again, the only base that that 3 is attached to is right here in the parentheses. It's not attached to that 2, so that 2 is not going to change. It's going to stay out here. Now that 4 is to the power of 3, so I'm going to write 4 to the power of 3. Our x becomes 2 times 3, and our y becomes 6 times 3. I'm going to simplify that. 2. That 4 to the power of 3 is 64. X to the power of 6 when we multiply the 2 times 3, and our y becomes, let's see, 6 times 3 is 18. Now we're not done. We still need to do that 2 times that 64. So we end up with 128, x to the power of 6, y to the power of 18. Now we're done, and we have simplified it all the way down. I emphasized a lot in the terminology video before this, the importance of writing out your steps. Hopefully, as you see me go through these problems, you'll recognize that there are a lot of places where a student can make a mistake. Even a teacher can make a mistake. I would never solve this problem without writing out the steps. So to avoid those simple errors, please write out your steps. Take it a step at a time. That way you don't make those simple errors and get the wrong answer. Number 12. I have a fraction raised to the power of 4. So I need to distribute that power of 4 to both of these numbers. So I end up with 1 to the power of 4 over 3 to the power of 4. 1 to the power of 4 is 1 times 1 times 1 times 1, which is just 1. 3 to the power of 4. 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is our answer here. Number 13. I have x squared y over 5 to the power of 2. Just like the last one, I need to distribute this power of 2 to everything in this parentheses. So I have x to the power of 2 times 2, y to the power of 1 times 2, right? It has that invisible 1, and then 5 to the power of 2. That's going to give me x to the power of 4, y to the power of 2, and then 5 squared is 25, because 5 times 5 is 25, and that is our answer. Number 14, I have two different fractions that I need to distribute their exponents to and figure out what those fractions are before I multiply. Because remember, we deal with exponents before multiplication in GMDOS in our order of operations. So I'm going to write this out. I get 1 to the power of 2 over 4 to the power of 2 times 2 to the power of 3 over 3 to the power of 3, because I need to distribute that 3 power, just like I did the other one. 1 squared is just 1. 4 squared is 16. 2 to the power of 3 is 2 times 2 is 4 times 2 again is 8. 3 to the power of 3. 3 times 3 is 9 times 3 is 27. Now I can actually multiply my fractions. So 1 times 8 is 8. 16 times 27 is 432. I'm going to reduce both these numbers by 8, actually. 8 will go into both of them. And I get 1 over 54 for my answer. Number 15. I have two groups of parentheses here. Before I combine my parentheses with the product rule, I need to use the power rule and then use the product rule. So I'm going to distribute my power of 3 to everything within here. So I end up with, let's see here, 3 to the power of 3, x to the power of 4 times 3, y to the power of 2 times 3, z to the power of 3. Our next parentheses, I'm going to distribute the 5. So I get y to the power of 5, z to the power of 4 times 5. Now I need to simplify these. So 3 to the power of 3 is going to be 27. And then x becomes x to the power of 12, y to the power of 6, z to the power of 3. Keep that in parentheses because I haven't done the multiplying between the two parentheses yet. And then I get y to the 5th, z to the power of 20. Now I can use my product rule. So I have 27. I'm going to write this a little bit lower. So I have 27. My x becomes 12. Oh, we don't have another x, so it just stays 12 actually. My y becomes 6 plus 5 when I combine both those y's. And my z becomes 3 plus 23. And that's going to simplify down to 27x to the 12th, y to the 11th, z to the 26th. Or excuse me, not 26. I wrote that one part wrong up here. Let me go back and fix that. I was already adding it in my head instead of writing down the correct answer. So that should have been 3 plus 20, not 23. And then let me fix this one. This one's going to be 23 now. Now we're correct. So again, that emphasizes write down your steps so you can actually see an error that you made and go back and fix it. If I hadn't done that, I would have gotten the answer wrong for sure. All right, number 16. We have a negative a to the power of 4, b to the power of 2. And then we have a negative a to the power of 2, b to the power of 3, and then that was to the power of 3. So let's distribute first. I'm going to get negative a to the power of 4 times 2, and then b to the power of 2. The next one, I get negative a to the power of 2 times 3, b to the power of 3 times 3. Simplify this out a little bit. I get negative a to the power of 8, b to the power of 2. Then I get negative a to the power of 6, b to the power of 9. All right, so let's now use our product rule. So I get negative a to the power of 8 plus 6, b to the power of 2 plus 9. And I end up with negative a to the power of 14, b to the power of 11. Scrunch that in there a little bit. All right, so that's our answer for that one. Now let's look at this cube over here, this rectangular block. We're gonna look for our volume in this particular shape. So let me write that here. We're looking for volume. And volume is length times width times height. So we're gonna use that. Our length is here, our width is here, and our height is here. So I'm going to plug in now. So V equals 3xy squared to the power of 3 times 2x times 7y to the power of 2. I'm going to distribute and get 3 to the power of 3, x to the power of 3, y to the power of 2 times 3. Keep that 2 times the x here, and nothing changes with that one. Distribute this, I get 7 squared y squared. Now I'm going to simplify that out. 3 to the power of 3. 3 times 3 is 9, times 3 is 27. Keep that x to the power of 3, y to the power of 6. We still have our 2x. 7 squared is 49, and then we have our y squared. I'm going to come up here. I'm going to rewrite this real quick so that we have room to finish out the problem. Make sure I transfer it correctly, don't make any errors. All right, so now we're going to use our product rule. 27 times 2 is 54, and then times 49 is going to give us 2,646. My x becomes x to the power of 3 plus 1, because this x had a power of 1. And then my y becomes 6 plus 2. Simplify that down. I get x to the power of 4, and then y to the power of 8. And we are done finding the volume of that block. All right, let's look at our quote. In most sciences, one generation tears down what another has built, and what one has established, another undoes. In mathematics alone, each generation adds a new story to the old structure. Herman Hankel. All right, guys, I hope you're having a great week. I'll see you in the next video. Bye.